Question 43, x equals 2 cos t, y equals 3 sin t. So dx dt will be minus 2 sin t, dy dt equals 3 cos t, and don't forget then you do dt dx, okay, which is equal to 1 over minus 2 sin t, right? Flip this, and then put dy dx. Okay, remember the chain rule is dy dt times dt dx, so 3 cos t times this, minus there in front. So then you get minus 3 over 2 cos t over sin t. Okay, now you could write that as minus 3 over 2 cot t if you wanted to. Okay, that's fine. But when it comes to then doing the equation of the tangent, right, I would stick to this here, right? And I'll tell you why in a minute. Because if we say then, look at b, parameters little p, so x will be 2 cos little p, y will be 3 sin little p, right? And dy dx will equal minus 3 cos little p over 2 sin little p. Now we're going to sub all this stuff into the equation, aren't we, of the tangent formula. And the reason why I would use this and not this is because we're going to have cos and sines involved with x and y. We don't suddenly want to introduce a third function, right? It's better just to keep it as 2, you know, cos and sines. And you notice the answer there's no cot there, isn't there? So we leave it like that, right? So just think that through and you'll be fine. So equation then, y minus y1 equals gradient then, x minus 2 cos p. Okay, take the 2 sin p up, 6 there, isn't it? Multiply through there, and then I hope you notice 6 sin squared, 6 cos squared, right? If we get all that to one side, of course that will factorize there, and that becomes 1, yeah? So you get exactly what they're looking for, right? Now it says then the tangent meets the x-axis at A, find the least value of the length OA. Now for this I would draw a little sketch, right, to see what's going on. So if you've got your curve, right, this is, you know, don't know what it looks like, it doesn't matter though, alright? It's the curve, the tangent at P, and it's saying this tangent meets the x-axis at A. Now, it says then find the least length OA. Now, OA, of course, is that horizontal distance there. So, if you think about it, all we need is that x value there, if you think about it, right? Because it wants OA, doesn't it? So, it's just the x coordinate, really, isn't it? The x coordinate here. Of course, what's great is at A, right, on the x-axis, okay, well, of course, y is 0, isn't it? The x-axis. So with this tangent, y is 0, so you end up having 3x cos p minus 6 equals 0. And then we can rearrange this, so because remember now we want x, don't we? We want x. So we can rearrange this, we get 6 over 3 cos p. Okay, so you need a bit of algebra there. Okay. And remember, yeah, we want OA, so we just want the x value, but we want the least. Okay, so we want the least possible x value. Alright? Well, least x is when this is at its least. Yeah? And this is at its least. Okay? Of course, when you've got a fraction, you want the least of it. It's when the bottom is at its max, yeah? Okay? So it occurs when cos p is max. Okay? Of course, cos p, if you think about it, cos p is between 1 and minus 1, isn't it? Right? If you think of the cos graph, it's between 1 and minus 1. So cos p is max. Okay? Is equal to 1, isn't it? That's the maximum it can be. So then the least will equal to 6 over 3 times 1. So you get 6 over 3, which is 2. So that's the least there. Okay? When cos is equal to 1. Okay? Excellent.